Alright, this video is for the partial quotients method of dividing. So we're going to set it up the same way as we did the other one, with the dividend on the inside of the division bracket and the divisor on the outside. But if you remember the other video before this one, we had to do the multiples of 37 of our divisor. So we would do 37 times 1, 37 times 2, 37 times 3, until we figure all of them out, right? With a little trick that I showed you. If you haven't watched that video yet, go back and watch it, and then come back to this one. Now this one, the partial quotients, it's a little bit more fun because you get to choose your own numbers to put up there. So here's what I mean. First, we're going to draw a big line like this. And then we're going to start seeing, well, how many times can I put 37 into the whole entire dividend? Not just one number or two numbers at one time. We're doing the whole entire thing, 7,000. 37 is a small number, and 7,148 is huge. And if you remember multiplying by 3, any number by 10 or by 100 or by 1,000, all you really do is add a 0 to the end, right? So if you multiply 37 times 10, it's really just 37 with a 0 behind it. It's 370. If you multiply 37 times 100, that's going to give you 37 with 2 zeros from the 100. So it's really 3,700. And that you can do that with any multiple of 10, like 1,000 or 10,000 or even 1,000,000 if you want to. So that would just be 37 with 3 zeros behind it, because 1,000 has 3 zeros. So it would be 37,000, right? All right, so you understand all that, I hope. And if you do understand all that, here is where this is kind of fun. Because right now what I'm going to do is I'm going to multiply 37 times 100. Because I know that's 3,700. I just showed you that, 3,700. And I know 3,700 is a little bit smaller than 7,000 something. But I'm going to have some left over, and that's okay. So when I do my subtraction, look at what I get. 8, 4, regroup here. So that's a 6. The 1 becomes an 11. 11 minus 7 is 4. And 6 minus 3 is 3. So I have 3,448. I can't fit another 100 in there, another 3,700, because that's going to be too much. It has to be lower than 3,448. So I'm going to cut my 100 in half. Half of 100 is 50. So I'm going to use that one, because I know that half of 700 is 350, right? Well, half of 3,000 is 1,500. So if I just add that, it's going to be 1,000 there. And 500 plus 300 gives me 800. So I'll change that 3 to an 8. And now I know that half of 3,700 is 1,850. And I'm just making up these numbers. You can choose another. You can choose 37 times 10 if you want to, instead of 50. But I just chose that one because I know that it was going to be a closer number. You'll see what I mean in a few minutes. Go ahead and finish this video watching it, and then you can go back and try some on your own, okay? So you can get the main idea of how to do this. So I'm going to subtract now, and I get 8 minus 0 is 8. Have to regroup on this next one, so the 4 becomes a 14. 14 minus 5 is 9. 3 minus 8, have to regroup again. So that becomes 13 minus 8, and that's 5. 2 minus 1 is 1. So now I have 1,598, 1,598. Well, now I'm going to say 37 times 25. Because you guessed it, half of 50 is 25. So half of 1,850, which is the one that I used before, I know that half of 50 is 25. Half of 18 is going to be 9, right? And I could have just do that, but actually what I said is half of 8 is 4, and then I said half of 1,000 is 500. So 500 plus 400 gives me that 9. So in the way you want to think of it, you can do that. So 8 minus 5 is 3, 9 minus 2 is 7, and then we're going to have to regroup on this one. So 15 minus 9 is 6. And then I still have another number. I still have a big remainder, so I have to keep going a little bit more. But now what I'm going to do, I know that 673 is not that big anymore. So I'm just going to multiply times 10 now. 37 times 10. That's just 37 with a 0 behind it. So that's 370. When I subtract, I get a 3 there, 0, and a 3. And I cannot fit another 10 in there, but I can fit 5 maybe. has half of 370. Half of 70 I know is 35, and then half of 300 is 150. So there's my 1 there, and if I add 50 plus the 35, I'm going to get the 85 that I need. So that's why I changed the 3 to an 8, because 3 plus 5 is 8. And when I subtract, I'm going to regroup. That 3 becomes a 2, the 0 becomes a 10, and then that 10 becomes a 9 because I have to regroup for this 3 to become a 13. 13 minus 5 gives me 8, 9 minus 8 gives me 1, 2 minus 1 gives me 1. So now I have 118. Well, I'm still not finished because 37 still can go into 118. I'm going to do one time. So when I subtract the 37 from 118, I get 1 there, I have to regroup, and I get 8. So I have 81. I can fit another 37 in there. So I'm going to extend my line, keep on going. That's okay if I run into the next problem space. That's okay. I'll show you how I'm going to fix that in a minute. So now I'm going to have this right here, and I'm going to say 81 minus 37. I'm going to have to regroup. So now I have 11. 11 minus 7 is 4, and 7 minus 3 is 4. I can still fit one more 37 in there, so I'm going to do one more right here to the side. So when I subtract one more time, I'm going to end up with, if I regroup correctly, I'm going to end up with 7 and 0. So there, I'm finished. Now I can add all of my partial quotients that I ended up with here on the side. So 100, 50, 25, 10, 5, 1, 1, and 1. And if I add those together correctly, I'll end up with 193. That's my quotient. And this number on the bottom that was left over, that 7, that's my remainder. So we still have a remainder, which is okay, and I'm still going to use the R in my quotient. But now I didn't have to do all my list of multiples. So it's kind of like one is better than the other if you prefer doing them puzzle piece with the multiples. But these partial quotients gives you freedom. It gives you the freedom to choose which number you're going to choose. And there is no right or wrong. You just try it, and as long as it's lower than the other number that you're trying to subtract from, then it will work at the end, because all you're going to do is add them all together. So it's kind of cool, I think. But if you don't understand it this way, then by all means do it the other way. If you don't understand it the other way, then do it like this. So what I want you to do is I want you to push pause, and I want you to work on this next division problem using this method that you just learned. If you need to go back and review it, go back and review it. Don't cheat. So that way you can see if you really know how to do it or not. And if you get stuck, then press play, and I'll explain you all the answers, the steps for this next problem. All right. Okay, so you're back hopefully, and here is the steps for this one. On this one, I'm going to do my long line here. I'm going to multiply 16 times 100. I know that's 1600, and if I do that correctly, my subtraction, I get 8,299. If I do another 100, it's going to be another big number when I have left over. So I'm going to multiply that times 4. Instead of 100, I'm going to do 400. So I'm just going to multiply my 1600 times 4. In other words, 16 times 4 is 64. So it's 6400. And when I subtract... Okay, let's move on to problem 2. Something happened to my iPad that I had to restart it. So hopefully this is the place where I left off. And if not, I'm going to start right here. Alright, so we have the dividend in this case is 2063. It goes inside of the division bracket. And then we have 45 as the divisor, so that goes on the outside. Then we're going to start doing our multiples of 45 so that we can have all the pieces that we need, right? Oh, wait a minute, we already talked about that in this case. Let me go ahead and fast forward that, because we are now on the partial products. That's where I left off. So hopefully you remember how we did all this, when we came up with all these numbers, and then at the very end we're going to line them up. The ones over here on the side, let's see, when we have a remainder of 7, we're going to line up all the numbers. Notice how you have all of these numbers right here? Well, we're going to have to line them up. Right now they're not lined up very well. It would have probably worked better if I lined them up as I wrote them down, but in case you're kind of sloppy with that, then this is a really good thing to do. Come back and write them all down where they're lined up. And then now that they're lined up, you can add them, and that's the number that is your answer on the very top, the quotient. And the bottom number, the remainder, that goes right next to the quotient. So I'm going to label that for you. And Remember, we use the R on the quotient, so we can say that that's final answer. So the second problem for partial quotients is like this. 9,899 divided by 16. So now we're going to do, well, we would do the multiples of 16 if we were doing the other way, the algorithm. But because we're doing the partial quotients, we are going to be just multiplying 16 by 100, and that gives me 1600. I believe I already talked about this one. I think I remember that. So then when we subtract, we get 99 for the first two zeros, and then 8 minus 6 is 2, and 9 minus 1 is 8. So I can tell that 1600 was not enough. I'm going to multiply that by 4. So it's going to be 400 instead of 100. And 0 times 4 is 4, 0 times 4 is 4. 4 times 6 is 24. Carry the 2 in my hand. And 4 times 1 is 4, plus 2 would give me 6. So that's perfect. That's really close to 8,000. And when I subtract, I'm going to end up with 99. Regroup here. That becomes a 12. That's an 8. And that's a 1. So I end up with 1,899. I know I can fit at least another 100 in there, because I already know what 100 is. 100 times 16 is 1,600. When I subtract, I get 9, 9, 2, and 0. So 299. So what I'm going to try now is I'm going to try 10. I know that 10 times 16 is 160. And again, I'm choosing all these numbers over here because these are easy numbers for me to work with. You can choose any number that you want. It can be hard or it can be easy like the ones I'm doing. So you can do the partial quotients. But why would you choose a hard number if you can use an easy number, right? So when you subtract now, I end up with 9, 3, and 1. So I cannot fit another 10 in there, another 16 times 10, but I could maybe do 5, so like half of that. So half of 6 is 3, or half of 16 really is 80, so, or 8. So there you go. I'm going to get 80 is half of 160, because half of 10 was 5. So 80, 9 minus 0 is 9, and 3 minus 0, I cannot do that. I have to regroup. That becomes 13. 13 minus 8 is 5. So I have 59. So what I'm going to do is I'm going to multiply now 16 times 2 and use that one. I know that's an easy one. That's 32. So when I subtract, I'm going to end up with 27. I can still fit another 16 in there. So I'm going to extend my line and put a 16 there. 16 minus 27 gives me 11. And that's it. My remainder is less than the number I'm dividing by, which is 16. So I know that I'm done. And my answer, it's going to be all of these numbers added together on the right. So 100 plus 400 plus 100 plus 10 plus 5 plus 2 plus 1. So we end up with 617. And that's going to be my quotient. I'm going to put that on the top of my division. That's where the quotient belongs. I'm going to put a remainder because we did have a number left over. And I'm going to box in my answer. So 617, remainder 11. I'm going to write it down over here next to my problem so I remember, hey, this is my answer. And there's my work shown on the other side. So hopefully this helped you figure out a new way to divide, which is partial quotients. It's a little bit less complicated than this one over here with the algorithm, because you don't have to have all of these multiplication facts. But you can choose your own numbers to divide by, like the ones you see here on the side, because you have freedom in this case. So it's up to you which way you want to divide, but I do need you to learn both of them. So go ahead and practice partial quotients and get good at it, and probably you'll like it better than the other ones. All right, thank you for watching.